Okay, it is lot of time. I think some will also issue for Google Earth Engine. So let me change the runtime. Click on the settings. Okay, let me try again. Okay, it take a lot of time. Okay, let me try to for a small study area. And remove the previous ROI and put it's a ROI. Okay, so we find out the zero because it show that less than 1% image is not available. So let me try to increase it, suppose 10%. So now you find out this type of imagery, but it is still also some place is not work. It means that for this type of place there is no image less than 10%. So just increase this. Suppose I put 20. So now it's fully fill up. We find out. Okay. So let's create that less than 20%, and we also find out it's also we create the median composite. And further, if you want, you can simply just display this imagery. Suppose red, green, and blue, and it's stressing of 98%. And apply. So now we can find out this type of imagery, but in this case we find out this type of cloud. Here you can see this white pixel, it's indicating about the cloud, but this type of cloud we can easily remove using Google Earth Engine. So these things I will try to explain about that how we can easily remove an cloud. For that our further class, okay, basically it discuss about that fourth number day how to remove cloud and haze from the satellite imagery. We also discuss in the fourth number class. Okay, so this is the process to work with median composite. So basically it's not a single image, it create the median composite from total 6 images. Okay, from 6 images it create the median composite, and you can get all of 6 images information. Basically this the total 6 images, we can easily find out all of information such as cloud cover. You can see also see about that image acquisition time. So all of information you also get from here easily. Okay, I think for the big study area, it creates some problem when you work with. So further, also try to check the solution and try to also explain about that. Okay, so when it will be big study area, it creates some problem now, but we can easily work with for the small study area. So further, I also try to show you that how we can easily work with the big study area. Okay, and also find out the solution. Or if just I open the coastal shape area and remove the previous RY, and I put the variable name as a ROI. So let's go try to check the result for that. Yes, we can find out the full coastal land shapefile. Okay, so further you can just click on here and add the band combination. Suppose I put here short wave infrared 2, near infrared, and blue, stressing 98%, and then apply. Then apply. So now you can easily find out this type of band combination for this type of study area easily. Okay, so this is the process to create the median composite, as well as also create the single date imagery. So further we also use this type of single date imagery or median imagery for the different types of remote sensing work. Okay, so any question about this topic, you can ask me please. Any question or any confusion? For filtering and displaying the satellite images. Okay, any question? Okay, I hope there is no question. So I also send you this type of code. You also try to practice for your own study area. Further, if there's any problem, then also inform me. Then I'll also try to guide you how we can work with that. Okay, so now we already write lot of code for displaying this type of satellite imagery and visualization. But in Google Earth Engine, we can easily shortest this type of code. Okay, in this case you can see for filter bounds I take a new variable, then filter metadata I also take the another variable, then filter date I take the another variable. But if you want, you can take only for the one variable and write all of function one by one. So these things is also possible. So let's go, I try to show you that how we can easily work with that. Just I comment all of those, just simply select and then control and forward slash. So now I just take only for the one variable. Suppose I put the variable name is that L9 and I add all of function one by one. So for that, just use here the dot notation and put here suppose filter bounds function, filter bounds with RY, then put here the filter metadata. I put here suppose cloud cover, less than suppose 20, and then put the filter date. I put the date suppose year of 2025, 1st January, from year of 2025 February 21. You can put any time period. So now I want to check how much image is available. So I just use at the filter, just call the variable name and use the size function. So now it's computing how much image is available after applying this type of filter bounds, filter metadata, and filter date. We found out the 26 images for my study area. So now I want to use all of images and create the median composite. Just use at the median. So now when I apply the median, you can see it create a problem. It show that this type of problem, we find out size is not a function. Okay, it means that size is only work for collection. Okay, size is only work for collection. Okay, but when I apply the median, then this variable stored the single median composite. Okay, just it work as a single image. So that's why it show this type of problem. Size is not a function. Okay, because size is only work for collection mainly more than one image, called as a collection. But when I apply the median, then it work as a single median composite image. So that's why it show this type of problem. Okay, so now size is not work because it's a median. So just I print only for this L9 and run. So you can see it's a image, not image collection. Okay, it's just a image. You can also use another function, it's called that type of function. You can also use, it's an object. Okay, single object we find out in here. So now it's a object or single median image, so that's why size function is not work. And then just simply use the cliff function with your study area, which is RY. So now we can easily display. Just use our map.add layer and call the L9 and just run the code. So now we can easily find out this satellite imagery for a study area. So now you can see I just take only for this code and we can easily work with that. So for the filter bounds, basically where you need the image, your study area, then how you need the image. So in this case, for my study area, between this time period, less than 20% is available. I put the 20%. Then put here when you need the image. Okay, so basically where, how, and when. Just use these three things and we can easily filter. So after filtering, we can create the median composite and then set with our study area. So now you can easily find out this type of imagery. So these same things you can also work with Python. Just I copy all of code together and then call the Python. So you can see warning. So it's some problem. Okay, I think some networking issue or some things. So that's why now for the big study we face this type of problem. Okay, so let me try to fix later. Just I paste. And for this sample, we need to use here the hash for comment. So this is the symbol of comment. Okay, so also remove the var keyword. So now this full things just use a bracket and also close this bracket. Let's just run it now. Just run it. Okay, so let me change the study area, basically shape file. These things I want to change. Just I copy this RY and change it. And now run. So now it's also okay. You can see, just add the layer. And also map dot. So now run the code, we can easily find out this. Okay, it loaded. So far they can easily add the band combination. Click on here. Suppose I put at that near infrared, then red and blue is tracing 98% and apply. So now you find out this type of band combination. Okay, and we can also use it for the different types of remote sensing work. So this is the process to visualize and filtering this type of satellite imagery. Okay, for the first time I try to explain all of code, so that's why I elaborate this type of things. But when you write the code, just use only for this code, then it will be okay. There is no problem. Okay, any question? Okay, if there's no question, so move to the next part. Okay, so let's go try to discuss about that another data set. Click on the Modis. So here we find out all of Modis data. So using this process, suppose this type of process you also apply for other Landsat collection. Okay, so you also try to filter for Landsat 8, Landsat 7, or Landsat 5, Landsat 4. So this type of satellite imagery, you also try to filter for your own study area. Okay, and further face any problem, then also show me the problem. Then I also guide you how we can easily fix the problem. So let's go to discuss about the another collection for Modis. So basically find out the lot of Modis product for daily or monthly or 8 days. So different types of Modis product we can easily find out. You can see the Terra vegetation continuous field yearly global 250-meter Terra land watermarks derived. Also you can see the Modis land use land cover data. Okay. Also you can see the Modis cover dynamics yearly global data. Modis leap area index data. Okay, surface radiation daily 3 hours data. So there's a lot of data we can easily access from the Modis globally. So this type of data you can see, this is the optical land aerosol optical data. We also find out, okay, it provides a lot of data, so we can easily find out in here. So you can see the vegetation indices monthly, crab vegetation index is 16-day global. So you also try to read this type of data description, then you can get the more better idea. So now suppose one data, suppose I want to use this data and work with that. So this same process also apply for the others data also. Just click on here. So now you find out all of information about this data. So basically it is the crab vegetation indices 16-day global 250-meter resolution. So this data, this is the data set provider, and it's available from year of 2000 to 2025, and this is the ID. Okay, this is the unique ID. So basically this is the directory. Okay, from this directory you can easily access the data. So first of all, these things you need to apply. Just I copy, and then suppose just I paste in the Python, just paste here, then give a variable name. Okay, suppose I put the variable name is data set. You can put any name. So now this is my image collection. This image collection, I just stored it in this variable, just on the code. Okay, there is no problem. And this data collection have a band. If you check it, this data collection basically it provides the two band, NDVI and EVI. NDVI mainly normalize difference vegetation index, and EVI mainly enhance vegetation index. I want to work for NDVI. Okay, so let's go try to do it. Just use a function dot select and select the NDVI. So now run the code. There is no problem. Okay, and this data set is available from time period. You can check 2000 to 2025. So you can simply choose a single time period or any time specific time period. So for that, use at the filter date function. Suppose I put this date 2025 1st January to February, and now run the code. So now we find out this type of information. I want to check how much images are available. So just use at the data set, use at the size function, and also apply the get info. Just run it. We find out the three images. Okay, so between this time we find out the three images between this time period. Okay, and it's globally we find out. So let's go try to display the map. So use your map dot add layer and then run the code. So now we find out the global NDVI map. You can see it shows this type of map. We find out it's available for the globally. Okay, we find out the globally NDVI map look like that, but I want to work only for the specific boundary. Or if you want to also add the visualization, so let's go try to add the visualization, then it look more better. For the visualization, if you check the data set, they already provide some color code, this type of color code. Just I copy and I want to just paste here. So this is the color code they are using here, default. So just remove the var keyword, it's not need, and the mean just put here the quotation, max also put the quotation, plated also put the quotation, and just call this variable name and connect after the data set. Also put the layer name. Suppose I put it's a world NDVI. Just run the code. So now we find out this type of NDVI map for the globally. So we can easily identify what is the high vegetation, what is the low vegetation. We can easily identify this type of things. But this NDVI map, I don't need for the whole world. Okay, I need only for the specific country or only for the specific polygon. Okay, so that's how I can work with that. So just import your shape file. So if you want, you can also use this data. We already know about that. This data, DOS data. It's provide you international country boundary polygon. Or let me open a new code editor. So we'll search here US DOS. So this is the data. I just click on here. So this data basically it provide you the international country boundary polygon. So just I copy this snippet ID for this data set, and I want to just import the data in here and give a variable name. I put the name, suppose it's a area, or put here ROI. Okay, so this ROI I want to filter. So just use here the dot filter and apply earth engine dot filter equal country name. I put the suppose Bangladesh. So now this RY, it stored the country boundary of Bangladesh. So just run it. Okay. And then if I just use here the clip function dot clip and put here the RY and run it, it show a problem. You can see this problem is that image collection object has no attribute clip. Okay. So it means that clip function is not work for the image collection. Okay. Because clip function is only work for the image. You can also check it. Suppose check the function of image. So this function we find out the clip. Okay. Clip function clip an image to a geometry or feature. So clip this function is only work for image, but in this case it's just a image collection. Okay, in image collection mainly 3 images, it's a total 3 images, so it's a image collection. So that's why it show this type of problem. We find out this type of problem. So now these 3 images I need to use, and further I need to make the image. So now I need to reduce. Suppose you can calculate the average NDVI or maximum NDVI or minimum NDVI, and then you can easily calculate. So let's go try to calculate the average NDVI. So for that I take a variable, suppose average NDVI, and call the dataset and apply the mean. And further when I apply the mean, then just use this 3 images and calculate the average pixel. Okay, and make a single image. So now I can easily apply the clip function, clip with study area RY. Okay, so just run it, and now I display the average NDVI. Just copy and paste. So just run it. So now you find out this type of NDVI map. Only for Bangladesh. Okay, so you can see you can get only for the Bangladesh. Okay, if you want, you can also add, click on here. You can also add the legend. You can see the legend. Just check mark and apply. So now it also added the legend of your map. Okay, so this indicating about the high NDVI, it's indicating about the low NDVI. Not only for that, any country you can put right here. Suppose just put the country name. Suppose I need the result for country, for suppose Pakistan, just put here that and run it, and then just run it. We can easily get the result for Pakistan boundary. So now I can easily find out this type of NDVI map, and you can also add the legend. Just click on here, and you can see the just check mark and apply. So now this legend is also added. So now I can easily create this type of menu, or you can also import your study area and also work with that. So these same things you can also apply for the Python, basically JavaScript API code editor. So for that, just apply the same process to work with that. Just copy this snippet ID and paste here. Then give a variable name. Suppose I put the name is that dataset, and this image collection have